Hello student, myself Dr. B. Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. So in this session, today we are going to discuss about a number of problems based on list concept. Now, the first problem in this session, we are going to discuss about leaders in an array. So, suppose you have been given an array A of positive integers and your task is to find out the leaders in the array. Now, who is a leader? So, an element of an array is said to be a leader if it is greater than or equal to all the elements towards its right side. So, the rightmost element or the last element is always a leader because there is no other element which is bigger than that. So, you have to write a program to print all the leaders in the array or list. So, an element is said to be a leader if it is greater than all the elements in its right side. So, and the rightmost element is always a leader. Now, let us understand in a list of positive integers how to identify a leader and how to write down the logic for this problem. So, let us take n is equal to 6. There are 6 elements in the array and the elements in this array are 16, 17, 4, 3, 5 and 2. So, you have to understand like this: 16, 17, 4, 3, 5 and 2. So, there are 6 elements are there. Now, if I will talk about, I have to traverse the array always from left to right. So, if I am traversing from left to right, if I will take the element 16, then I have to check whether any other element towards its right is bigger than that. If no other element is bigger than 16, then 16 will be leader. But in this case, the next immediate element is 17, which is bigger than 16. So, 16 cannot be a leader. Now, consider the next element, which is 17. Now, compare the element 17 with its rightmost elements. So, we'll compare with 4. Okay, 4 is smaller than 17. We'll compare with 3. Okay, 3 is smaller than 17. 5 and 2. If we'll compare all the right side elements, then all are smaller than 17. So, 17 will be a leader. So, here 17 will be the leader. We have to write in the output. Now, the next element that we are going to consider is 4. Now, towards its right, we'll compare with 3, 5 and 2. And we'll see that 3 is smaller than 4, but 5 is bigger than 4. So, 4 cannot be a leader. So, 4 cannot be a leader. Okay. Next element we will consider is 3. So, if we will consider 3, compare with 5 and 2. 5 and 2 are towards the right of 3. So, 5 is bigger than 3. Okay, fine. And 2 is smaller. So, 3 cannot be a leader because one element which is bigger than 3 is available. Okay. Next element we are going to consider is 5 and towards its right only 2 is there. So, 2 is smaller than 5. So, 5 is a leader. So, we'll write in the output 5 as the leader. Now, the last element is 2, the rightmost element, and towards its right no other elements are available. We have come to the end of the array or list. So, the last element is always a leader. So, we'll write 2 as the output. So, in this particular array, the output is the leaders are 17, 5 and 2. I hope you understood how to find out a leader. Now, consider another example. Suppose there is an array containing the elements 1, 2, 3, 4, 5 and 2. Now, the index numbers are 0 to 5. Again, 6 elements are there. If you consider 1, then almost all the elements are bigger than 1. So, 1 cannot be the leader. So, if you consider 2, then bigger elements than 2 are available. So, 2 cannot be a leader. Now, if you consider 3, then 4 and 5 are bigger than 3. So, 3 cannot be a leader. If you consider 4, 5 is bigger than 4. So, 4 cannot be a leader. Now, if you consider 5, then towards its right only 2 is there which is smaller than 5. So, 5 is a leader. So, 5 is a leader. And if you consider 2 and it is the last element in the array, so the rightmost last element is always the leader because no other elements are there. So 2 is also the leader. So in this example, 5 and 2 are the leaders. So we have understood how to find out leaders in an array, and let us start writing the code. Now, we will first write down the solution of this problem using brute force approach. Now, what is a brute force approach? Let us first understand. So, in the driver code, first of all, we have taken an array with some elements, and we have written a function called print leaders, and we are passing array and the length of the array. What is the length of the array? So, length of the array is 6, and the array and the length we are passing. So, here the size is 6 and the array we have passed. So what we will do, we will compare the first element with its second element. If there is a bigger element, then that cannot be leader. If there is a smaller element, means if all the rightmost elements are smaller, then that element will be a leader. So first we are iterating through the entire list. So for I in range of 0 to size, that means 0 to 6, size is 6. That means it will iterate through all the elements. So let us understand all the elements are 16, 17, 4, 3, 5 and 2. So the index numbers are 0, 1, 2, 3, 4 and 5. Okay. So 0 to 5 it will iterate. When it reaches to 6, then this loop is going to stop. Okay. So first time the value of I is equal to 0. So for j in the range of I plus 1 to size. So j is running, I is running from 0 to 6 and j is running from 1 to 6. So here j is equal to 1. So we are talking about this element, and I is equal to 0. We are talking about this element. So I is 16 and j is 17. Now we are comparing. If array of I is less than equal to array of j, that means 16 is less than equal to 17. Yes, 16 is less than 17. Then break. Okay, that means that element cannot be a leader. Okay. Now next what we will do? We will shift our I. Now I becomes 1. So now I becomes 17. Okay, and j will run from j next time will run from 2 to 6. Okay, so we'll consider I as 17. I is pointing to 17 and j is pointing to 4. So this is a of I and this is a of j. Right. Now we are checking. 17 is less than equal to a of I is 17 is less than equal to a of j. Yes or no? 17 is less than 4. No. So if it is not less than 4, then what will happen? This loop will iterate. Okay. Now j will change. Now j will change to 3. So 17 will be compared with 3. 17 is less than equal to 3. Yes. Okay. Sorry. No. So again the loop will run. So j will be shifted. So now 17 will be compared with the next element 5. Okay. So 17 is not less than equal to 5. Again the loop runs. So now 17 will be compared with 2. So that means 17 is compared with 4, 3, 5 and 2. So with all elements we have compared and we have seen that 17 is the bigger element, and by comparing all the rightmost elements we have checked that 17 is the bigger element, so it is a leader. So after completion of this loop, what we will do? We will check that if j is equal to size minus 1, okay, print the array of I. So the ith element will be a leader. So 17 will be a leader. Okay. So in the similar way, the program runs and prints one by one leaders. So this is the brute force approach. In this brute force approach, we have used two loops. Okay, one outer loop and one inner loop. So the outer and inner loop is running based on the number of elements in the array or list. So the time complexity is order of n into n, which is nothing but order of n square. Okay, and space complexity is only 1. So with this brute force approach, we found that the time complexity is very high, which is order of n square. Now let us discuss about if there is any other solution or approach available to solve this problem. Now let us discuss another solution for solving the same problem, leaders in an array. So, this solution is called finding the leaders by finding the suffix maximum. So, what is suffix maximum? Now, let us discuss this problem. Now, suppose the array is containing these elements 16, 17, 4, 3, 5 and 2, and what we will do, we will find out the maximum element from the right. So if you will traverse from right to left, the maximum element, the first element is 2. Okay, we have taken one answer array and answer list, and we have stored that particular number into the answer. So 2 we have taken. We are considering the elements from right to left, and we are finding the maximum elements from right side. So the first element, as there is no other rightmost element towards 2, so 2 will consider as the maximum element, and let us store this as the leader in an answer array. Now consider the second element. So now the second element, maximum element from right is 5, because 5 is bigger than 2. So let us consider 5 is the rightmost element, and let us store it. 2 and 5 are the leaders. Okay. Now consider the next element. Next element is 3. So if you consider 3 towards its right, 5 is bigger than 3. Okay. So 3 cannot be a leader. So we are not storing into this leader's answer. So it is still containing 2 leaders, 2 and 5. Now consider 4. It will consider 4. Now towards its right, one bigger element 5 is available. So 4 cannot be a leader. So we cannot write in the answer. So we are still the answer array contains only 2 and 5. Now consider the next element is 17. Now 17 is the maximum element because it is bigger than all the rightmost elements 4, 3, 5 and 2. So let us write 17 into the answer. So these 2, 5, 17 are leaders at present. Now consider the next element from right to left. The last element is 16. So if you consider 16, 17 is bigger than 16. So 16 cannot be leader. So finally, we have traversed the array from right to left, and we found that 2, 5 and 17 are the leaders in the array. Now, if you consider this particular logic, then what is the time complexity? Using this particular logic, what we have identified, we are taking only a single loop and we are traversing from right to left. So, the time complexity for traversing a loop with n elements is order of n. And the space complexity is constant space, that is order of 1. Okay. So, the same thing is explained with another example. Okay. Now, let us see how to write down the code for this particular solution. This is called finding the suffix maximum solution. Now, in this solution also, let us take the array and write a function called print leader by passing the array and find out the length of the array. So, length of the array is 6. So, we are passing size as 6. Okay. Now, how to find out the maximum element from right? So, our purpose is to traverse from right to left and finding the maximum element. So, maximum element from right is nothing but the rightmost element. So, which is nothing but a of size minus 1, which is 6 minus 1, is a of 5. A of 5 is nothing but 2 here. So, if you draw the array, it is 16, 17, 4, 3, 5 and 2. So, 0, 1, 2, 3, 4 and 5. So, the size minus 1 element is 2. So, 2 we are storing from right side. Okay, right from maximum element from right it is. Okay. Now, we are printing that element. So, 2 will be the answer. 2 is printed here. So, 2 is printed here. Okay. Now, let us traverse reverse from right to left. So, for I in range, size minus 2. So, if this is the size minus 2. This is size minus 1, you know that. This is size minus 2. Because our index starts from 0. So, size minus 2. So, that is from here to up to minus 1. And we are traversing from back side. Okay. So, if maximum element from right, okay, maximum element from right is at present 2, is less than the array element. So, the array element A of I is what? 5. 2 is less than 5. 2 is less than 5. Yes. Okay. So, print that array element. So, print that array element means 5 is the leader. So, 5 is the leader. It is getting printed. Okay, and maximum element from right is array of I. So we found our next maximum element from right, which is nothing but the array of I, which is 5. Okay, now if you run the loop again, so now the size minus, so now the next element we are going to consider is 3. So maximum element is how? Maximum from right is now at present 5. Is it less than A of I? A of I is how much? A of I is our 3. So 5 is less than 3? No. So if it is no, then we are not going to print it and we are not going to change our max from right. Now in the next iteration, now we are coming to size minus 1, that is size minus 4. Next element is 4. So maximum element is 5. Is less than 4. Okay. 5 is less than 4. So again it is no. So the leader we are not finding. Next element is 17. So 5 is less than 17. Yes. So then max from right is going to change to 17 over here. And 17 we are going to display. Okay. In this process, all the elements will be checked and the array or the list is traversed from right to left only once. So the time complexity is only order of n and space complexity is constant. So using this suffix maximum approach, we have reduced the time complexity from order of n square to order of n. So this is a better approach for finding the leaders in an array. Now, next question that we are going to discuss today is cyclically rotate an array by 1. So, how will you rotate the array cyclically? Example, given an array, cyclically rotate the array clockwise by 1. So, consider an input array 1, 2, 3, 4, 5. It contains 1, 2, 3, 4 and 5. So, you have to rotate the array clockwise. So, we have to rotate the array clockwise by 1. So, if you rotate the array clockwise, then what will happen? The array will look like this: 5, 1, 2, 3 and 4. So, the last element will come here and the array remaining bits will be shifted by 1. So, how will you solve? How will you bring the last element to the beginning? So, store the last element in a variable. So, what is the last element? Is 5. So, let us say you are storing the last element in a variable. Let us say x is equal to 5. And you are then after storing, this place is empty. You are shifting all the elements by one place. You are shifting by one place. So, if you will do a shifting by one place, then this beginning place will be empty. So you can replace the first element with the element x, which is 5. And this is the simplest brute force approach to solve this problem. Okay. So what is the time complexity required for solving this problem? So it is order of n, because n is the number of elements in the array. So we need to iterate through all the elements. Rightmost element you have to take it into a variable. All the remaining n minus 1 elements you have to shift by one place. So where n is the number of elements in the array, then the time complexity will be order of n. And space complexity will be order of 1, which is a constant space. Now let us see how to write down the code for this. So first we will try to solve this problem using the brute force approach. Now, using the brute force approach, let us see the driver code. Initially, we have taken an array of 1, 2, 3, 4, 5, 5 elements. Find out the length n is equal to 5 elements is there. And let us print the content of the array as it is. So, for I in range of 0 to n, print the content of I. You can write, or simply instead of writing this particular loop, you can simply write print ARR. So, in Python, it will be printing the content of the array. Otherwise, you can use the procedural approach. Using a loop, you can print the content of the array. Both will be fine. So, your array will be printed as 1, 2, 3, 4, 5. Okay. Now, we are calling a function called rotate and we are passing the array and the number of elements, which is 5. Okay. So, the control will go to the rotate function. Now, what is the first task in brute force approach? The rightmost element, we have to keep it into a variable. So, which is nothing but a of n minus 1. last element we are storing into a variable. So our array contains like this 1, 2, 3, 4 and 5. 0, 1, 2, 3, 4. So n is equal to 5. 5 minus 1 is 4. So a of 4, which is nothing but x contains 5. Okay. Now, next what you have to do? You have to shift all the elements by one bit. Okay, by one place. Okay. So for I in the range of n minus 1, because there are n minus 1 elements are there total. Okay, till we reach to the 0th place by 1 by 1. That is okay. Now, what a of I will contain? A of I will contain the element of a of I minus 1. So, if it is a of 5, sorry, a of 4, then it will contain the element a of 3. Okay. So, 4 will be shifted here. Then 3 will be shifted here. 2 will be shifted here. 1 will be shifted here. So, finally what will happen? A of 0 place will be vacant. So, it is empty because all the elements are shifted. So, to this place, we have to shift x. So, you can see that once the shifting is done through this loop, finally a of 0 is empty and we are storing the element x into a of 0. That means the element x is equal to 5. What you have stored will come here. So, it will be 5, 1, 2, 3 and 4. So, with this, our array or list has been cyclically rotated by one place. Now, once the rotate function is over, we can print the content of the array. So, the rotated array is, for I is in the range of 0 to n, print the content or simply write print ARR. So, the new content will be printed, which is nothing but 5, 1, 2, 3 and 4. So, this is the simplest brute force mechanism to cyclically rotate an array by one place or one position. Okay. Now, let us discuss whether is there any other solution possible for solving the same problem? Yes, it is possible. Now, the simplest solution for solving this problem is using slicing operator. So, slicing are the very powerful operator, or the colon is used as the slicing operator, which is very powerful in Python. So, using that operator, we can easily do it in just one line code. Okay. Now, let us understand how to do it. So, A is the array, A is the original array, and we are calling rotate array and passing the array. Okay. Now, how to get the new array after doing cyclical rotation by one place? So, which is nothing but array of -1 colon. Okay. -1 colon means this is the starting place. This is start colon stop. In Python we write. So, -1 means that the last bit, that is the last element. Suppose our array is like this, 1, 2, 3, 4, 5. Python we are using two types of indexing. This is left to right 0, 1, 2, 3, 4. Right to left it is -1, -2, -3, -4 and -5. So, -1 colon start to end. So, this is which is nothing but the lastmost element, which is nothing but 5 plus ARR of array of colon -1 means up to -1 means excluding -1. What are the elements are there? So it is nothing but the element 1, 2, 3 and 4. So if you will add it or if you will do concatenation, you will find 5, 1, 2, 3 and 4. And you can simply print using the star operator the content of the array. You can print and you will find that it is 5, 1, 2, 3, 4. That means cyclically it is rotated by one place. So, this is the simplest approach to solve this problem also. Now, after discussing these two problems, leaders in an array and cyclically rotate an array by one, next problem that we are going to discuss is finding the common elements in three sorted arrays. Okay. Now, let us understand the problem statement. Given three sorted arrays in non-decreasing order, print all the common element in these three arrays. Okay. Now, let us understand through example. Suppose array 1 is containing 1, 5, 10, 20, 40 and 80. You can see that They are in increasing order. Okay. And array 2 contains 6, 7, 20, 80 and 100. And array 3 contains 3, 4, 15, 20, 30, 70, 80 and 120. So from all these three arrays, we have to find it out the elements which are common in all the three arrays. Okay. So if you look at the element 20, 20 is available in array 1, it is available in array 2 and also it is available in array 3. So it is the common element, so in the output common element 20 will come. Similarly, if you talk about 80, 80 is available in first array, in second array and also in third array. So 80 is also the common element. So 20 and 80 will be the output which are the common element in all these three sorted arrays. Similarly, in this example, 5 and 5 are the common elements. Okay. Now, what is the simplest brute force approach? So, a simple solution is to find the intersection of these two arrays. And intersection will give you always the common elements and the intersection elements. You have to store it into a temporary array. And then first and second arrays intersection you have taken. Whatever is your result, you store it into a temporary array. And then you take the intersection of the temporary array with the third array. So again you will find it out the common elements between temporary array and also the third array. So finally the common elements in all these three arrays you can find it out easily. Okay. So intersection operator in Python can be used to solve this problem in just one line. So if intersection operator is not allowed to use, then how will you solve this problem? Then one of the brute force approach or naive approach is called, you have to go for iterative solution. Iterative solution means what? You have to iterate through the arrays from left to right and you have to make them match with the elements of second array and third array. So if any element is matching with the first and second array and also it is matching with the third array, then that is the common element, which is also a naive solution or brute force approach. Okay. So what will be the time complexity? The time complexity of this solution will be order of n1 plus n2 plus n3. So n1, n2, n3 are the sizes of three different arrays. So this is the time complexity. Now let us understand the solution for this problem without using intersection operator. So we will go for a naive approach using the iterative approach first. Now let us see the driver code. We have taken directly the three different arrays A1, A2 and A3 and we are calling a function find common elements by passing the three arrays A1, A2 and A3. Okay. Now if you are using iterative approach, first of all you should know what is the length of the array. So we are taking three variables n1, n2 and n3 to find out the length of individual arrays. That means when our loop is going to stop, for that reason we have to know that how many times the iteration should go on. So for that we have to find it out the length of the three arrays. Okay. Now we have taken three variables I, j, k, which is initially 0. Okay. Now let us start the loop. For I is less than n1. So what is the value of n1 here? n1 is 6. What is the value of n2 here? It is 5. And what is the value of n3 here? It is 8. Okay. Now initial value of I, j, k are 0. So I is 0. So 0 is less than n1 means 0 is less than 6. Okay. Yes. And j is also 0. 0 is less than n2. n2 means 5. Yes, it is true. And k is also 0 is less than 8. It is true. So with these three conditions, the while loop is becoming true. That means we are going inside the loop. Now, after going inside the loop, we have to compare. Okay. So, how will you compare? If A1 of I, 0th element, 0, 1, 2, 3, 4, 5. Okay. 0th element of A of Y, which is nothing but 1. 1 is same as A2 of J. J is also 0. So, 1 is same as 6. Okay. No. So, this is a if condition. If 1 is equal to 6. No. So, this is false. And false and something is false. The other side may be true or false. It is false only. Okay. So A2 of J is equal to A3 of K. So A2 of j is how much? 6 is equal to A3 of k is 3. 1 is equal to 6. So false and false is false. Okay. Now what we will do? So if the elements are, that means it indicates that the elements are not common. So if the elements are not common, print A1 of I and increment I, j, k. So I, j, k are incremented. Now I becomes 1, j becomes 1, k becomes 1. So if this if condition is false, what will happen? This part will not be executed, right? Okay. Okay. So we'll come to this part. A1 of I, is it less than A2 of j? A1 of I is how much? It is 1 first time. Okay. 1 is less than A2 of j, which is less than 6. Yes. So if the first element is less than 6, because they are in the increasing order, if it is 6, then increment I. So I becomes 1 here. Okay. This condition is true here. So this condition will be executed. Okay. Now, so this way it is going to compare the elements wherever this condition is satisfied, wherever this condition is true. That means the element of I, j and k are same. Then that particular element will be printed. Again I, j, k will be incremented. So in this way, through this naive approach, it is just doing the comparison and then iterating by incrementing their indices. So when all the indices reach to their maximum value or to the end of the array, this loop is going to stop. So there is only one loop, but the iteration is going on through the size of n1, through the size of n2 and n3. So it is order of n1 plus n2 plus n3, which is order of n only. Okay. And the space complexity is only constant space, which is order of 1. So this is one of the solution, but you can write a better solution than this. So let us understand how to solve the same problem using another approach. Okay. Another approach is using the set concept. Set is one of the powerful concept in Python. So let us see how to solve using the set concept. Suppose A1, A2, A3 are the original arrays and length of these three arrays is N1, N2 and N3. Now call a function find common elements and pass these three arrays and their sizes. So now when you call this, now control comes to this function. Okay. Now here we have created set 1, set 2 and set 3. 3 sets which is initially empty. Now in this example, we are running the loop for I in range of n1. So first loop will be iterated in through the all the elements will be iterated from in the first array for I in range of n1. S1 dot add of a1 of I. So in this array, whatever elements are there, you add one by one elements to the set. Now set S1 becomes like this. It will look like 1, 5, 10, 20, 40 and 80. So once all the elements are added, this for loop will be over. Now we'll come to the second for loop. In the second for loop, same thing for I in the range of n2, S2 dot add of A2 of I. So all the elements of the second array will be added to S2 set. So the set becomes 6, 7, 20, 80 and 100. So second set will be created. Now how to write down the logic? Now we will come to the third for loop. For I in the range of n3, so we are iterating through the third one. If A3 of I is first element is how much? 3. 3 is in S1. The element 3 is in S1. If it is there in S1 and A3 of I is in S2, that is 3 is either in S1 and S2. Suppose the element is there in both. Okay. So 3 is there in both? No. So in this case, it is not there. So if it is not there, this condition becomes false first time. So if it is false, then what we are doing? If A3 of I is not there, not in S3, then it's not there. Then what you are doing? We are adding to your S3. Okay. Now, next element you check for 4. 4 is there in S1. It is not there in S1. 4 is there in S2. It is also not there. Okay. Then we'll check the next element 15. 15 is there in S1? No. 15 is there in S2? No. Next element we are going to check is 20. 20 is there in S1? Yes, it is there. So this will be true. And 20 is there in S2? Yes, it is true. So true and true is true. So if this condition is true, now if that is not there in S3, yes, S3 is an empty set. S3 is an empty set initially. So you add that element 20 to this empty set. Okay, and print that element. Okay, fine. Now, next similar way we will check for 30. So 30 is there in S1? No. 30 is there in S2? No. Okay, next you check for 70. It's not there. 80. 80 is there in S1? Yes. 80 is there in S2? Yes. 80 is not there in S3? Yes, it is not there. So we have to print it and you have to add it. So 20 and 80 will be added to the set S3. So what the set S3 is finally going to contain? It is going to contain only the common elements which is there common in S1 and S2. Which is common in S1, S2 and S3. So using this set concept, we can solve or we can find out the common elements in 3 sorted arrays also. So we have seen here 2 different solutions. One is using iterative approach. One is using intersection operator that you can directly do it. And third one we have seen that how to use the set concept to find the common elements in 3 sorted arrays. Now, next we will discuss about another problem. Find 3 elements from different 3 arrays such that A plus B plus C is equal to sum. Now, let us understand the problem statement first. Now, given 3 integer arrays and a sum, the task is to check if there are 3 elements A, B, C such that A plus B plus C is equal to sum and A, B and C belongs to 3 different arrays. Now, let us understand how to solve it. Now, A1, A2, A3 are 3 different arrays and they have given the sum is 9. So, you have to choose an element A from A1, you have to choose an element B from A2 and you have to choose another element C from A3 such that there is sum. If you will sum A plus B plus C, if you will do, you will get the required sum. Okay. Now, let us take, if you will take this as A is 1 and if you will take 2 as B and if you will take 6 as C and if you will do A plus B plus C, which is nothing but 1 plus 2 plus 6, which is equal to 9. So, 9 is the required sum. So, you have to choose individually 3 different elements from 3 different arrays such that their sum is the required sum what is asked in the question. Okay. Now, let us understand another program. So, these are the 3 different arrays and your sum, required sum is given as 20. So, if you will take any combination of the elements A, B, C, you can try with all the elements. So, you are not getting the sum as 20. Therefore, the output should be no. So, if that required sum is you are finding, then you should print yes. Otherwise, you should print no. Okay. So, what is the naive approach or brute force approach? So, a naive approach is to run 3 different loops. Okay. And check the sum of those 3 elements from 3 different arrays, which is equal to the given number. Okay. If find, then print it exists or yes. Otherwise, print not exist or no. So, in the naive approach, 3 different loops you have to run and you have to take each element and produce their sum and you have to equalize with the sum. If it is same, then print yes, otherwise print no. So, let us see how to write down the code using the naive approach. Now, naive approach is very simple. So, we have taken directly A1, A2, A3 are the 3 different arrays. Now, we are finding and the sum is also given in the question. Now, we have to find it out the length of the arrays because we are using naive approach where you have to iterate through the loops or you have to iterate through the array. So n1, n2 and n3 are the lengths, and we are writing a function called find triplet. So you have to find a triplet A, B, C, okay, by passing the arrays and their length and the sum, original sum what is given. So if you will find any triplet which is same as the sum, then print yes, otherwise print no. Okay, so how to get the triplet? Let us understand. So when you call this function, the function call or the pointer goes there. Okay, now let us use the naive approach where three different loops we are going to use. So for I in the range of 0 to n1, okay, for j is in the range of 0 to n2, for k in the range of 0 to n3. That is, you are iterating through all the elements. So starting in the beginning, I is equal to 0, j is equal to 0 and k is equal to 0. Okay, so the elements are 1, 2, 3, 4 and 5. This is array A1. A2 is your 2, 3, 6, 1 and 2. And A3. A3 is 3, 2, 4, 5 and 6. So I is equal to 0 is the first element, j is equal to 0 is the first element and k is equal to 0 is the first element in these three different arrays. Now find out the sum. So what is the sum? 1 plus 2 plus 3. Okay. So what is the required sum now? It is 6. 6 is same as sum? No. So written, you have to, it is no. So what you will do? You will iterate through the innermost. Okay. All elements you check. For the innermost loop, then the outer, then the outer. So if any triplet is available, which is same as the sum, it will return true that time. Otherwise, it will return false. Okay. So this is the one of the simplest naive approach for finding the triplets from three different arrays so that their sum is equal to the given sum. Now, let us understand how to solve the same problem using set concept. Now, in this approach, what is the time complexity? As you are using loop within loop within loop, three different loops, and the sizes are n1, n2, n3, so the time complexity will be order of n cube, which is very high, and auxiliary space complexity is constant space, but the time complexity is order of n cube. So we should write down the solution in an optimized way so that we have to reduce the time complexity. So let us see how to write down in an alternative way so that the time complexity will be reduced. Okay. Now let us go for another approach using the set concept. Same problem can be written in multiple ways. So you need to think of which solution will give you the less time complexity. That is called the optimized solution. So you can try in multiple logics in multiple ways. So here I am trying in another way where I am trying to reduce the time complexity from order of n cube to order of n square. You can also try in some other logic. Let us understand. So A1, A2, A3 are the given your arrays, and N1, N2, N3 are the calculated sizes or lengths, and sum is given. Sum is given as 9 in this example. So you are writing or calling a method called find triplet, and you are passing all this as the parameter. So if you will found any triplet is true, then you are printing yes. If this function returns true, then print yes. If the function returns false, then print no. Right. Now let us understand how the function works. Now we have created a set. Initially the set is empty. Now what we will do? First, for I in the range of n1, s dot add of a1 dot I means in the first array, whatever elements are there, you are adding to this set. So what are the elements? 1, 2, 3, 4, 5 will be added to s. Okay. For I in range of n2 and for j in range of n3. So these two loops, two arrays we are iterating at a time. If sum is equal to, if sum is nothing but 9 minus a2 of I, first element in a2 which is nothing but 2, okay, minus a3 of j, first element is 3, is in s. So 9 minus 5 is 4. 4 is in s, we are asking. 4 is in s, we are asking. That means what will happen? So 2, 3, 4 will be a triplet. 2, 3, 4 will be a triplet. It is there. Yes. Okay. Now, next time, what will happen? So already S1 contains only the contents of A1. Now, next time what will happen? So again, sum is 9 minus A2 of I. A2 of I is the A2 of I is the same, that is 2 only, but this loop will iterate till it ends. Okay. Now next time it will be 2 minus 2. So is it in S? 9 minus 4 is 5. Yes, it is there. So it is a triplet. Okay. Fine, it returns 2. Right. Next time 9 minus 2 is common. So next time the value is 4. So it is how much? It is 6. 6 minus is 3. Okay. 4, 2, 4 and 3 is also a triplet. It is in S. Yes, it is in S. So this is also true. Next time 9 minus 2 minus next element is 5. Okay. So 5 minus 2 is 7 is 2. So is in S. Yes, it is there. Okay. Okay. Like that it is going to find out the triplets in by running this particular logic. So if it is returning true, then print yes. If it is returning false, then print no. So this is the way we can find out or choose 3 different elements from 3 different arrays so that their sum is equal to the given. Now, next question that we are going to discuss is to find out the missing number in an array. How to find out the missing number in an array? Let us understand the problem statement. Given an array of size n minus 1 such that it only contains distinct integer in the range of 1 to n. Okay, find the missing element. Now, example, n is equal to 5 elements. So, the elements are 1, 2, 3 and 5. So, the elements are stored in this position, the 0, 1, 2, 3 and 4. So, it is there. It contains distinct integers. So, 1 is there, 2 is there, 3 is there and 5 is there. So, which element is missing? So, 4 is the missing element. So, 4 is the missing element. Similarly, next example, n is equal to 10 and these are the elements. So, you have to store and you have to check which element is missing here. Okay. So, in this example, you have to write down a function called missing number that takes an array and n as the input parameter and returns the value of the missing number. As we are dealing with a single array and we can do it using naive approach. So, the time complexity, expected time complexity is order of n and the constant space complexity is required. Now, let us see how to solve this problem. So, to solve this problem, there is a simple solution over here. Now, this is the array and n is the length of the array. So, n is the length of the array. So, length of the array is how much? It is 5. Okay. Now, first you have to create a temporary array. So, n is equal to 4 here. Sorry, 4 elements are there. So, n is equal to 4 here. We have to create a temporary array with how many? 0 into n minus 1. N minus 1 is 5. So, 5. So, 5 zeros we are creating. Temporary array with 5 zeros we are creating. Okay. Right. Now, for I in the range of 0 to n, temp of AR of I minus 1 is equal to 1. So, what do you mean by this? AR of I. What is the value of I? I is equal to 0. So, AR of I contains how much? 1. 1 minus 1 is 0. That means, which is nothing but, how much you should write? In this is temp of 0. Temp of 0 will contain 1. Okay, next time I becomes 1. So, temp of 1 means 2. 2 minus 1 is 1. 1. So, which is nothing but temp of 1 is equal to 1. Okay. Now, next temp of this is 3. 3 minus 1 is 2. 3 minus 1 is 2. It contains also 1. And temp of next time it is 5. 5 minus 1 is 4. Which contains also 1. That means how my temporary array looks like? It looks like 1, 1, 1 and 0 and 1. Okay. Now, this is the output after running this for loop. Now, let us understand this one. So, in which position the value is 0, that is the missing number. That is the logic here. So for I in range of 0 to n plus 1, okay, fine. So it is 0 to 5. If temp of I is equal to 0, first time, what is the value of I? 0. So is it containing a 0? No. Second time, is it containing a 0? Wherever a 0 is available. So in this place, 0 is available. 0, 1, 2, 3, 4. So at I is equal to 3, 0 is available. So as the index starts from 0, so in the fourth place, the missing number is available. So what you will do? Answer is equal to I plus 1, which is nothing but 4. 3 plus 1, which is nothing but 4. This is the way the answer is computed. So we have taken one temporary array of all zeros, which is nothing but the size of the array plus 1. And we have initially stored all zeros, and we have written the logic to fill the values with 1 wherever the numbers are available. Wherever the numbers are not available, it will be still 0. So with this logic, wherever 0 is there, that will be our missing number. So this is the required logic. So this is one of the very efficient logic for finding the missing numbers in an array. So today in this video, we have discussed a number of problems related to list. And all these problems are competitive coding problems, and this will be helpful for you to write many competitive exams and also placement related exams. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.